Hello, Algebra 1. Today we're going to be looking at quadratic functions. We're going to be looking at the linear functions that compose quadratic functions and the relationship between them. And then we're going to get a chance to practice some vocabulary words about various characteristics of a quadratic function. So let's go right into our first example here. We're given three functions, f of x, g of x, and h of x. We're going to first plot some points for f of x. So if I plug in -2, I get -5. So keep in mind I'm plugging it here. If I plug in -1, I get -4. If I plug in 0, I get -3. If I plug in 1, 1 minus 3 is -2. 2 minus 3 is -1. 0 and 1. From there, let's carefully plot out these points. -2, -5 would be right here. -1, -4. So if you notice, all of these points are going up 1 over 1. Right, our slope here is just 1. Let's look at g of x. So g of x in this case is x plus 1. So if I plug in -2 there, -2 plus 1 is -1. I'm going to carefully just plug in the appropriate numbers. You should get something like that. And then from there, I'm going to carefully plot out those 5 points, or those multiple points. Again, we get another line here. And lastly, we're going to graph h of x, which equals f of x times g of x. If you notice here, h of x is f of x times g of x. So we want to take the values from the t-charts for f and g. So for example, if I plug in -2 into my h function, I'm really going to be taking -5 and multiplying to -1, and I'll get 5. If I plug in -1, I'll be multiplying -4 and 0, which is 0. And we're going to carefully just multiply the corresponding y coordinates together. And you should end up with something like this. And then from here, we're going to carefully plot these points out. So -2, 5 would be left 2, up 5. -1, 0 would be right here. 0, -3 would be down here. 1, -4. 2, -3. 3, 0. And then 4, 5. And if you connect these, you end up with what we call a parabola. Right? There's a couple of things that we want to talk about concerning this parabola. First off, let's look at the x-intercepts. If you remember the x-intercepts, that would be this point right here. And that would be this point right here. They're the points at which the graph hits the x-axis. Next, we're going to be looking at y-intercepts. Here we just have one y-intercept, and that's just where it crosses the y-axis, which would be right here. And then we have words like increasing and decreasing. So where is this graph increasing? If you notice, it's when the graph is going upwards from left to right, which would be this portion of the graph is increasing, right? So if you notice, right of 1. So let me put right here, this is where it's increasing. And then decreasing, so here we can say it's increasing for x values that are greater than 1. And then decreasing would be on the other side. It would be here, right? You notice how the graph is going downwards. So I would say that this portion of the graph is decreasing. And so the graph is decreasing when x is less than 1, right? We're looking at the x values. Here I can say that the domain is all real numbers. Right? These arrows right here indicate to me that this graph is going to be going forever and it's going to be extending outwards. So for any x value that I plug into my function, I will always get some sort of y value. Range will be the set of all y values. In this case, it will be greater than or equal to -4, because if you look at every single point on this curve, the smallest y value is here at -4, and everything is greater than or equal to that value. And so here's some vocab words that we can use to describe this parabola. So make sure you understand how we graph this parabola, how we took the corresponding values for f and g and we multiply them together, we get the points for h, and at that point when you connect the dots, you end up with this parabola. Let's go on to the next page. So here they say, let the graph of f of x be represented by the red line, and let the graph of g of x be represented by the blue line. They want us to graph the function h of x, which equals f of x times g of x on each coordinate plane. So we're going to be multiplying the y coordinates, right, of the corresponding points. So to graph these, we're going to be looking at an x value, and we're going to be multiplying the y coordinates of those points. And that's going to be the new y coordinate for h of x, right? Because again, h of x is just f of x times g of x, right? It's a product of these two linear functions. All we're doing is we're multiplying the outputs. So for example, if I take this point here and this point here, I look at the y values, one's at -1, one's at -3. If I multiply -1 and -3, I do get +3. Let's look at these next values over here. The y values are 0 and -2. And when I multiply those together, I just get 0. For the next ones, I have 1 and -1. When I multiply those together, I get -1. For this here, you'll get 0 again. Hopefully you can see how I got that. And let's go over one more. Here I have 1 and I have 3, right? Those are the y values. And when I multiply them together, I get 3. And so when you connect these, you end up with another parabola. So at this point, I want you to pause the video and try number 3 on your own. And when you're ready, press play. So if you did the same reasoning we did earlier, right, we're just multiplying the y coordinates. I'm going to first start with these because I know that one of the values is 0, and 0 times anything is 0. So I know I get this point right here. And similarly, if I look on the right side over here, when I look at these 2 points, that red line hits at 1, 0. And again, it has a y value of 0, and 0 times -4 is still 0, so I get these 2 points here. Let's move on to these points right here. This is -1 and -3. Those are my y values, and when I multiply those together, I get +3. Here I have -2 times -2. You notice how they both have the same y value, which is -2. -2 times -2 is +4. That gives me that point there. And then on the right side, moving over, I have -1 times -3, and that gives me +3. We can actually go one more. We can actually get one more point. Let's go 1 times -5, and that would be -5, right? Similarly on the left side, if I took 1 times -5, I get -5. And then from there, you could graph this carefully, and you'd end up with a parabola, but this one's open downwards. Hopefully you get an idea of how we can graph a parabola based on the 2 lines, right, that compose it. Understand that we're just multiplying the corresponding y values, and that's going to give me the new y value for my parabola, for my quadratic function. So for number 4 and 5 here, they don't give us any values now. And based on that, we need to draw a sketch of what h of x is. And so for this one, I'm going to be looking at the x-intercepts because I know that this has a y value of 0, and 0 times anything is still 0, and I get the same thing here. Now when I look at these 2 points, I notice that they both hit the same point. And again, we're looking at the y values, right? The y coordinates of both points are negative. So if you take a negative number times a negative number, I know I get a positive number. And based on that, I feel like I have enough information to know that my parabola is going to be open downward. So that's the sketch of my parabola. At this point, when your video says your turn, I want you to pause the video, try number 5 on your own, and when you're ready, press play. So if you use the same technique earlier, I'm going to start by taking these points here, the x-intercepts of the lines, because I know those will be the x-intercepts of my parabola. Right? We don't know whether this parabola is open up or down, but what we can do is pick a sample point. For example, let me take these 2 points, one above each other. Now, if you notice, both of the y values are negative. If I take a negative number times a negative number, I'm going to get a positive number. So I know I'll get some point above here. Let's pick a point in between, say here and here. One's positive and one's negative, right? And if I multiply those together, I'm going to get a negative number. So I know that I can just put a point here. I don't know where it is, but somewhere there. Moving over, if I pick, say, these 2 points, they're both positive, right? A positive number times a positive number is still positive. So I'm going to just put it over here. And so based on that, this would be a rough sketch of my parabola. Right? We didn't know exactly what the values were, but we can take the positive and negative values and multiply them together and determine whether we get a positive or negative value in the end. So hopefully you get an idea of how you can graph parabolas based on the lines. So in Google Classroom, there should be a link. It's going to be a link for Desmos Activity that's going to help you build some vocabulary, some keywords that we need to know. So when you're doing the activity, I want you to pause this video. And then when you're done with the entire activity, I want you to press the play because I'm going to be going through the last 2 challenges to see if you got those correct. So try the Desmos Activity now. So for this challenge, it says which of these statements are true for the parabola shown here. Select all that apply. So the vertex is on the y-axis. So I know my vertex is right here, 3, 0. But if you notice, that's on the x-axis, not the y-axis. So I know that's not true. Now this graph is concave down, right? It's not smiling, it's frowning, right? So I know that's true. It has one positive x-intercept. Looking at the graph, you notice that it crosses the x-intercept at 3, 0. That is a positive number, so that is a positive x-intercept. It has one negative y-intercept. Looking at where the graph crosses the y-axis, it's somewhere right there. And if you notice, that is a negative value, right? Negative 4.5, so that's also true. Now, line of symmetry at y equals 3. This one was kind of tricky because y equals 3 is a horizontal line, right? Now, x equals 3 would be in the line of symmetry, right? That would be a vertical line, but y equals 3 is a horizontal line, right? It consists of all the points whose y coordinate is 3. How'd you do on this? Hopefully you're able to figure out which 3 statements were true. Let's see how you did on challenge 2. So for challenge 2 here, we're going to be creating a function. Here we're going to be creating a parabola that meets these requirements. So the vertex is below the x-axis. It's concave up. It has one positive x-intercept, one negative x-intercept, and line of symmetry is at x equals 2. So I'm going to start with the line of symmetry at x equals 2. What that tells me is my vertex has to be situated somewhere at x equals 2. And so for now, what I'm going to do is move this blue line somewhere at x equals 2. Now it says that the vertex is below the x-axis, which we have here, right? It says it has to be concave up, which we have as well. It needs to have one positive x-intercept, and here I have a positive x-intercept, and you need one negative x-intercept, which I have right there. And so if you made a graph like this, that'd be correct, right? You really have to check those 5 conditions though. Make sure the vertex is below the x-axis. Make sure your graph is smiling, right? Make sure it's concave up. Make sure you have one positive x-intercept, one negative x-intercept, and you want to make sure that your vertex had an x-coordinate of 2, because that's where your line of symmetry is at, right? The line of symmetry is what cuts the parabola in half, right? The parabola is symmetric with about the line of symmetry. So hopefully you're able to do well on challenge 2. When you're done with it, go back to your worksheets. So for this last worksheet, this is your exit ticket for today. I give you a parabola here. What I want you to do is I want you to go through the word bank, and I want you to try to fill in as many as you can. Not every word will be used, so be aware of that. And then, yeah. So as usual, when the video says your turn, pause the video. And when you're done, press play and let's see how you did. All right, let's go right into it. The graph of a quadratic function is a U-shaped curve, which we call a parabola. Right? It's like a U shape. It's a letter U. This quadratic function is a product of 2 linear functions. If you remember in the previous worksheet, what we did was we took these 2 lines, right, and we multiplied them together. The end result was a parabola. The blank of this function is at -1, 0, and 5, 0. So -1, 0 is right here, 5, 0 is right here. And if you notice, they're both on the x-axis. Those must be my x-intercepts. The values -1 and 5 are also called the blank of the function. So those are called the zeros of the function. And the reason why they're called the zeros of the function is because those are the values that make the function equal to 0. Right? The y values are 0. The point 2, -9 is it. Well, 2, -9 is right here. It's the lowest point. We know that's called the vertex. It can also be the highest point, which is the lowest point on this parabola. The blank value is 9, which is the y coordinate of the vertex. So -9 in this case would be the minimum value. Always want to look at the y coordinate of the vertex. There is no maximum value. I hope you can see why. If you look at this graph, it's always going upwards. There will never be a there will never be a maximum value because it's going to continue growing and growing and growing forever. The parabola is symmetric about the, you could have put axis of symmetry or line of symmetry, because they mean the same thing, right? And there's a vertical line, x equals 2. That would be this line right here. That's my axis of symmetry. The parabola has a blank at the point 0, -5. 0, -5 is right here. If you notice, that's a point on the y-axis. That's going to be my y-intercept. And it's concave. Here you notice it's a smile, right? A parabola smiling. That means it's concave up. The blank is all real numbers, so this is what we call the domain. And the range, which is a set of all outputs, is y greater than or equal to -8. The function is blank for x less than 2. So when we look at the values for which x is less than 2, 2 is right here, right? When you look at the values less than 2, pay attention to how this graph is behaving, right? This function, do you notice, is going down, 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 right? It's always decreasing till it hits 2. And then after 2, it's increasing, increasing, right? It's going up. And so here we can say the function is decreasing for x less than 2 and increasing for x greater than 2. So the only word we didn't use here was the word down, right? Because this was not concave down, this was concave up. So guys, make sure you understand these vocab words and how we can use these vocab words to describe all the characteristics of a parabola. Guys, this is day 1 of quadratic functions. Make sure you come back next time when we start looking at quadratic functions in factored form.